Good morning. Myself Prabha Ranji, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is truncation and rounding from the unit 4 that is finite wavelength effect in digital signal processing. Let I discuss. In fixed point and floating point arithmetic, the size of the result of an operation, that is sum, addition, and multiplication, may be exceeding the size of binary used in the number system. In such cases, the low order bits has to be eliminated in order to store the result. The two methods of eliminating these low order bits are truncation and rounding. This process is also referred to as quantization via truncation and rounding. The effect of rounding and truncation is to introduce the error, whose depends on the error of bits eliminated. The decimal numbers that are encountered as filter coefficients, sum, product, etc. in DSP application will be lie in the -1 to +1. The this is the most important, which is quantization step size, which is represented by q equal to r divided by 2b, and limit is +1 to -1. Apply this, we can get the r equal to 2, which means 2 divided by 2b. Finally, the quantization step size is 2 power minus small b. R is equal to range of decimal number. B is represented the binary size of binary including sign bit, and small b represent the size of binary excluding sign bit. This is the quantization step size for sign magnitude, one's complement and two's complement. Fixed point. Okay. Truncation. Truncation is the process of reducing the size of binary number by discarding all bits less significant than the least significant bit that is retained. In the truncation of a binary number to b bits, small b bits, all the less significant bits beyond bth bit are discarded. In fixed point number system, there are three different types of number representation. The effect of truncation and positive number are the same in all the three representation. That is sign magnitude, and another one is one's complement and two's complement. This is the any positive unquantized input output characteristics of quantizer used for truncation. First is any positive unquantized number in the range of 0 to 1 into 2 power minus b will be assigned quantization step is 0 into 2 power minus b. In the range of 1 into 2 power minus b to 2 into 2 power minus b is assigned by 1 into 2 power minus b. Likewise, negative number minus 1 into 2 power minus b to 0 will be assigned by 0 into 2 power minus b. Okay. Truncation error e power t e suffix t equal to n suffix t, which is fixed point binary number quantized by truncation, minus capital N, which is represented by unquantized fixed point binary number. This is case 1, case 2, case 3. Okay. This is the range of error in truncation of fixed point numbers. Okay. Yeah. The truncated floating point number is unquantized floating point binary number, which is represented by nf plus nf into epsilon suffix t, which is the relative error due to truncation of a floating point binary number. Okay, relative error due to truncation is epsilon t equal to n TF truncated floating point binary number minus unquantized floating point binary number divided by unquantized floating point binary number. Also, here you can see a range of errors in truncation of floating point numbers. Next one is rounding. Rounding is the process of reducing the size of a binary number of finite word size of b bits such that the rounded b bit number is closest to the original unquantized number. The rounding process consists of truncation and addition. If the bit next to the least significant bit, the bit that is retained is 0, then 0 is added to the least significant bit of the truncated number. If the bit next to the least significant bit that is retained in is 1, then 1 is added to the least significant bit of the truncated number. The input-output characteristics used for rounding. This is the input-output characteristics. Also, rounding error equal to fixed point binary number quantized by rounding minus unquantized fixed point binary number. Also, rounding floating point binary number nrf equal to unquantized floating point binary number represented by nf plus unquantized floating point binary number represented by nf into relative error due to rounding is epsilon r, which is epsilon r equal to nrf minus nf divided by nf. Yeah, okay. If you have any doubt, you can ask me through the comment. Okay, we will meet in next video series. Thank you.